Finally, let's see cooperative threads implemented with letcc. Here's an example using threads, assuming that we've already defined them. We'll see the implementation in a second. We've got a count function here, and we're going to run count inside two different threads. Down below, we make one thread that takes in a dummy value and then calls count with A. Another thread takes in a dummy value, calls count with B. And then we run swap. Swap says stop the current execution up at the top level and switch to one of the threads. Count lets another thread take a turn. It prints out its label, followed by a number, and then calls itself again with the number +1. So our thread A will print out A0, A1, A2. And our B thread will print out B0, B1, B2, and so on. Let's jump over to the implementation. So we've got thread code up at the top, and then we have count down below that we just saw. Let's run count and see what our threads do. Yes, they are hard at work. They're printing out lots of A's and B's. Okay, and the thing to notice is that these A's and B's are interleaved. The threads are taking turns even though we did no kind of scheduling over here on the user code. We just declared two threads and then said swap out to the first one. Here's our implementation. Let's skip over pause for a minute. We've got a mutable queue of threads. Function thread takes in a continuation and then appends that onto our queue of threads. Function swap takes the first thread off the queue, updates the queue, and then calls that thread with the dummy argument. The real magic happens up inside pause. When we call pause, we grab the current continuation, save it in a thread, and then swap to a next thread. That means down below, when we create our two threads, they go on the queue. Then when we call swap, we execute the first thread with that dummy argument. So we jump inside our first function that takes in a dummy that calls count. We go to execute count, we see a pause. Pause saves the current continuation, which is the rest of this thread body. That's up there in a new thread. Then it swaps to the next thread. We get to thread B, we also pass in a dummy argument, we go into count, count pause, saves the current continuation, and then swaps in the next thread. The next thread is our thread A with the remainder of its body. So that will print out the label and then recur on count. Jump back up with new arguments, then pause again and finish off the B body. So these threads keep making new continuations and keep taking turns printing out A and B. And with that, we're all done. We have seen cooperative threads implemented with letcc.